All right, next we have Ty Dunn. As we mentioned earlier, Heavybit is one of our sponsors, and Continue is one of the Heavybit companies. So give it up for Ty. Woo.
Awesome. Thanks for having me tonight. I'm going to be talking about how you can own your own AI code assistant. So to kick things off, if you're not familiar with Continue, it's an open source AI code assistant. So you can go to github.com right now, go to continuedev/continue and see all of the source code for an AI code assistant, and then jump into VS Code, jump into JetBrains, and begin using it. And you can hook it up to whatever models you want. So if you want to run models locally with Ollama, if you want to self-host models like 405B and use it, if you want to plug it into Claude Sonnet 3.5, whatever you want to plug it into, you can on the model side, and then also on the context side. There's quite a bit of configurability and customizability that allows you to decide what context you bring in, when you bring it in, and where you bring it in. And so today we're going to be talking about how you can actually use it with entirely open source models and entirely within your own environment as a result. And so this is very attractive to large organizations who don't want their code data leaving their environments for privacy, security, intellectual property reasons, as well as like some of the most cutting edge organizations who, rather than kind of buy a product in this space, are actually building their own and training their own models and doing those things. And so when you first encounter AI code assistants, let's take autocomplete as an example, as the canonical example. You start using it, right? You're coding and ghost text starts to appear and you get these code suggestions, right? It's presented to you as this robot AI pair programmer. How it works, what models it involves are all kind of a black box. And so what we kind of realized as we started to play with many of these tools, or even before these tools existed, is that it's actually not an AI code assistant. It's more of a compound AI system, right? Meaning that it's not a single monolithic model. It's actually multiple models. So most of these systems you're using now have at least one model for chat. They have one model for autocomplete, usually one for embeddings, and often many more, depending on kind of the different aspects that they have. And more specifically, I want to put out there that they actually are a particular kind of compound AI system, which I'm calling an AI software development system. So this is a very simple example. Depending on which AI code assistant you use, it will look a little bit more complex, but generally it's an IDE or an IDE extension, or extensions for many IDEs that have some kind of local context engine, so a kind of RAG system locally that's often bringing in context about the particular code base you're working in, stuff from your IDE, things like that. And then kind of requests are being sent off. Sometimes this could be entirely on your own laptop if you wanted to, but often, especially if you're using commercial APIs, right, it's leaving not only your environment, but not only your computer, but also your environment, and going out and sending a prompt and getting a response. But you have one usually for chat that's at least 400 billion parameters, or if not larger, one of the frontier models. Autocomplete models tend to be between 1 and 15 billion parameters. I think CodeStroll is 22 billion, so that's the upward size that I've seen on those models. And then often you have a remote context engine where you're pulling in lots of code bases, lots of data from the software development lifecycle, and then you're embedding it all and you're kind of creating your own vector DB, or someone's creating it and pulling it in, and that's how they're kind of answering it. And so usually when you interact with these AI code assistants, they're presented to you like this, the black box, the robot. But if you kind of peel back that black box, they often look something similar to this. And so we at Continue are focused on empowering you to own your AI code assistant so that you kind of can have these three things, right? First, that you can understand how it works, right? Until I presented this, some of you had the black box mental model. Understanding this is really critical, because when you get a suggestion that's wrong or bad, being able to then go and reason through the system as to why you got that suggestion is critical to be able to try and change the future, so you don't get that suggestion that you think is bad or wrong in the future. And so the next step is usually then to measure it, right? So you have a system that you understand. Now you instrument it to know how it works. And then because you have access to the system, you can customize it, optimize it, personalize it for your use case, and make some changes, and then measure kind of, did that actually improve? Go talk to your developers and see, did it actually lead to better suggestions from them? And so to set up a custom AI code assistant in your environment today with Continue is pretty simple. Like we saw earlier from one of the talks, right? You deploy Llama 3.1 405B as your chat model. That's currently the best model for any kind of chat experience within Continue or with code. The two most popular at the moment are VLLM and OLLAMA as the approaches to actually deploy those. Then you need an autocomplete model. CodeStroll from Mistral is not open source model. It's an open weights model, but you can deploy it within your own environment, and it is by far the most performant autocomplete model. But you can also use like StarCoder 2 or DeepSeek Coder. It's just not as performant as CodeStroll if you want a model that has a more permissive open source license or open weights license. And once you've deployed those two models, what you then do is you take the development data. So as you use Continue, every time you hit tab or don't hit tab, basically all of kind of the actions in IDE are instrumented and dropped on your local computer by default. And what we're seeing organizations do is start to ELT that data. So they're extracting it, they're loading it, and they're transforming it in a central place so that they can then do fine tuning, like we just saw in a previous talk, right? And then to do continued pre-training and maybe one day actually pre-training their own models from scratch. But before they do that, they want to just see, okay, how are people using it? What are they using? How many days are they using it? So here we're visualizing one organization's use of different models in the summer and how many tokens were generated by each of those models. And so once you have this system set up, you can actually go about improving it. And so there's many ways that you can actually go about improving it. I'll talk about 3 today. I'm happy to kind of chat about more afterwards. We're very much in the early days of enabling people to improve their custom AI code assistants. So the first one is quite simple, but quite powerful for organizations. So because you have full access to the system, inserting a proxy in between kind of the models and the ID extensions is critical. So for example, you're not sending your credentials to the OpenAI or Anthropic API keys or API developer consoles. So any outgoing requests, you can start to kind of filter on the data that's coming out. You can start to add on governance on top of that, keep track of kind of who's using what models, how they're using them, and actually start to record, okay, in our code base, right, these folks are using these models to create this. So what is the who, what, when, where, and why of how code that was generated is becoming part of your code base. And then on the flip side, incoming requests, a very common one is you want to ensure you're not violating licenses of GPL code or other kind of code that's publicly out there and might have been used by models. And so you check before you give that suggestion. Filtering is a powerful but pretty simple approach, right? You're adding quite a bit of heuristics to do that. The next one we're seeing folks do is actually building their own remote code RAG systems. So in the Continue docs, you can see a little blueprint that we've created based on what we've learned from folks where they're actually setting up their own embeddings models, their own vector DBs. They're doing a chunking strategy that's good for code. And then they're creating a script that they run, putting it on a server, in some cases adding re-ranking, adding repo maps in front of it, creating pretty powerful systems where they're actually making all of their code data, and even more than that, their Jira tickets, their Confluence docs, data code that or context that is available for their custom AI code assistant. So in Continue, you can at the code base and go and grab all of that data, and you have full access to kind of the system that is retrieving those results and providing them as context. And last but not least, in terms of examples I'll give today is about fine-tuning continued pre-training. So on the left side, kind of just a diagram from the original CodeLlama paper. I think it's a great example where they did a mix of both of them. So from Llama 2, they ended up taking billions of tokens and creating the original CodeLlama, and then they took another many billions of tokens that were Python specific. And the way that they did this is through continued pre-training, where they made a model that became more performant, not just at coding, but then eventually particular language. And so we're starting to see people explore, could I do this for my unique way of building or for a specific programming language that I have within my organization? And super excited in the last few weeks, I've gotten to know the Unsloth folks, another open source framework out there for helping you with fine tuning. And they're also enabling people to do continued pre-training. So I'm very, very excited about what we're going to see. And so with Continue, you have full access to your data to be able to do this. And so to wrap things up, we worked with about a dozen or so platform development teams at organizations to write this piece called amplified.dev that just outlines kind of our view of a future where we want to see developers be amplified and not automated. And so this entire thing is about, okay, being able to have an awareness of your system, measure it, be able to improve it, and what are kind of the things that we need as organizations to make sure that we're setting ourselves up for a future where this is the case, right? As you start to automate your job more and more with AI, you begin a a future where you start to work on the system that did the job you used to do. So very similar from when we move from assembly to higher level programming languages, engineers aren't going to go away. They're just going to move up a level of abstraction is our point of view. And so to wrap things up, we're hiring software engineers in San Francisco. Scan this QR code if you're interested in working with us. And thank you for taking the time to listen to me.